Can you split this array into two halves with the exact same sum? Pause for 2 seconds. 11 on one side, 1 plus 5 on the other. Both sum to 11. The real question is, how does a computer see this instantly? Here's the formal problem. Given an array of positive integers, can it be partitioned into two subsets with equal sum? For 1, 5, 11, 5, yes. But for 1, 2, 3, 5, the total is 11. An odd number can never split into two equal integer halves, so the answer is immediately false. Now, the entire trick. If two halves are equal, each must sum to exactly total divided by 2. So the question transforms, is there any subset that sums to total over 2? Stop. We have solved this before. This is exactly subset sum equal to target from the last video, wearing a disguise. And here's why finding just one half is enough. If some subset sums to total over 2, the leftover elements must sum to the rest, which is also total over 2. Find one half, and the other half builds itself for free. So the implementation is almost embarrassing. Compute the total. If it's odd, return false right away. That's both a correctness check and a free shortcut. Otherwise, call the subset sum solver we already wrote, with target equal to total over 2. 3 lines. That's the whole solution. Complexity comes straight from the solver we used one. One subset sum call with target total over 2. Time, order n times sum. Space, order sum with the one-dimensional rolling array. 2 pitfalls trip people up. First, forgetting the odd total early exit. Without it, you may prove a fractional target. Second, and more important, rederiving a brand new DP from scratch when the real skill was to recognize a problem you've already solved. So here's the takeaway to carry into every interview. Before writing any DP, ask, is this a problem I've already solved, wearing a disguise? Partition equal subset sum is just subset sum with target equals total over 2. But what if the array can't be split evenly? What's the smallest possible difference between the two halves? That's partition with minimum absolute difference, next episode. Until then, try the practice set, check partition ability by hand, reconstruct the actual subsets, and if you're brave, partition into k equal parts.